Hey class, so today we're going to be finishing off our section 1 of chapter 3, which deals with the coordinate system and reading graphs. So in this portion we're going to focus on the coordinate system and how this relates to certain equations. So before we were dealing with taking this chart of data and creating points out of them, and then charting those points on our coordinate system and finding out our relationship in this. So an example, because all of these points, let me get the pen ready, because all of these points were increasing with each year, that told us that the money is increasing every year. So now we're just going to focus in on those data points. And now we're going to connect those data points back to equations. And specifically equations with two variables, because remember these coordinate points, or ordered pairs as we call them, corresponded to an x coordinate and a y coordinate. Okay, so with this x and y coordinate, we can then have an equation, and we can plug these equations into, we can plug these coordinates into our equation, and if we get the same number on both sides of our equation, that tells us that this point is a solution to our equation. So that means if we put 3 in as our x, then when we solve for our y, we should find negative 2. It's kind of like a forwards and backwards relationship here. So let's just do an example, and we'll see if we get the same number on both sides of our equation. So plugging in 3 for x here, and let me just make this more explicit actually. So from this ordered pair, we get these relationships. X is equal to 3, and y is equal to negative 2. Okay, now that I've written out that explicitly, let's plug those in. And then when we see our y, we have 5 times negative 2. This is equal to negative 4. So let's check it. 2 times 3 is 6, and 5 times negative 2 is a negative 10. 6 minus 10 is negative 4. And putting in our right side of the equation, we see that, yes, we do get the same number on both sides of our equal sign. So this says 3, negative 2 is a solution. So for this next problem, I want you to pause the video and try to figure it out yourself. Determine whether negative 1, 6 is a solution of this equation right here. Okay, for this second example, we see that we find it is not a solution. So when we plug in our values, negative 1 and 6, what we wind up getting is a negative 9 on this left-hand side. This negative 9 is obviously not equal to 5. Therefore, our ordered pair is not a solution to the equation. Okay, moving on, we want to kind of do the reverse of this. We want to find the ordered pair that is a solution to our equation. But this time we're only given one component of our ordered pair. So in example 6 right here, we see that we have the ordered pair 4 blank. So that means that x is equal to 4, and we need to solve for y. And we solve for y using this equation right here. So the way we do that is we plug in 4 for our x, and then get our y alone, and solve it like we would any equation. So plugging our x in, we get negative 2 times 4 plus 4y is equal to 4. Negative 2 times 4 is negative 8. Then we have to add 8 to both sides in order to cancel this 8 out. And when we add 8 to this 4, let me just write it out explicitly. We add 8 to both sides, so 4 plus 8 is 12. So that means our equation goes to 4y is equal to 12. And now we want to divide by 4. When we divide 12 by 4, we get that y is equal to 3. So that means our ordered pair is then 4, 3. I'll just box both of these things in. And this is how we do these types of problems. So go ahead and try example B. Pause the video now and I'll talk about the solution in a sec. And the solution you should have gotten is x equal to 1/2. I forgot to write the new ordered pair now, but it is going to be 1/2, -2. So this time, the only thing that changed is our y is given to us, and we had to solve for x. Another thing about this problem was remember that when you plug in a negative number to your y, or to your variable, you want to keep that negative sign with it. And if there's a negative sign in front of it, just leave that alone too. So that once you get your variable in as it was originally written, and you have a negative next to it, then you can say, oh, well, okay, there's two negatives which make a positive. Okay. So that's the solution for example 6. Now we move on to a new view of the same type of problem. So we want to complete the table for the equation y equals 7x plus 2. In this table is basically taking ordered pairs and stacking them on top of each other. So this is saying we have an ordered pair, -2, blank. We don't know the y. And then the second row is saying we have an ordered pair, blank, 30. And we don't know the x. So you want to solve for both of these ordered pairs using that equation. So in the first instance, we get -2 is equal to 7x plus 2. Did I plug that in right? I did not plug that in right. Hold on. I can tell immediately. So, our y coordinate is not given to us, so it's still unknown. However, the x coordinate is given to us, so we plug that in for x. So 7 times -2 plus 2, which gives us -14 plus 2, and -14 plus 2 is -12. So our ordered pair is -2, -12. So you want to put that right there. Okay, go ahead and solve the rest of this. Okay, when you solve the rest of this, you get 4 as your solution for x. And we plug that into our table, and now our table is complete. Here we have another example, and I want you to try to do this entire table on your own. Here, the equation for the table is y equals 3x, and you have 3 ordered pairs that you need to fill out. And here are the solutions that you should have calculated. I actually think is there a mistake? No, that's fine. Okay, so these are the solutions you should have calculated. And now let's move on to something that combines both word problems and tables. So these word problems are not as bad as you may think originally. This is just saying the computer was recently purchased for a small business for $2,000. The manager predicts the computer will be used for 5 years and the value in dollars y of the computer in x years is y equal to -300x plus 2,000. Complete the table and graph below. So what this is telling us is that this computer loses $300 per year. So at year 0, plugging in our x, we see that the value is $2,000. So before I continue, I kind of skipped over something. This table right here is the exact same as this table right here. So remember when we were dealing with bar graphs, you could have bar graphs that would lie horizontally or vertically. It doesn't change anything other than just the visualization of it. It still has the same meaning, right? The farthest to the right is now the tallest horizontally, like if you flipped it. What I'm trying to say by saying that is that before we were looking at the rows as ordered pairs, here we're going to just look at the columns as ordered pairs. So the first ordered pair would be 0, 2000. Our X input is 0, and our Y output is $2,000. And we can continue this for each column here. So when we do, what we're going to be doing is subtracting 300 for each year. So this is going to be 1700. This will be 1400. Then we'll get 1100, 800, and 500. So if you don't see my methodology of just subtracting 300 each time, go ahead and plug in all of these X values and see for yourself that this is in fact what you get for each ordered pair. Now the second part of this is going to be a graphing question, and it might be better for me to zoom out a bit. So we want to graph this table below. Okay. I hope this is still readable, but we want to graph this table below right here. So we have 1, 2, 3, 4, 5, 6 years that we want to cover. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 boxes. That means that if I skip these two and put our first year here, I can skip a kind of miniature line here each time, put a year, and I'll still have some room left over. So 0, 1, 2, 3, 4, 5, and 6. Nope, we only go to 5. Okay. Let me go ahead and erase that. Okay. So now we want to graph these Y values. And when we graph these Y values, we want to put the lowest value to start right here. And we want to be able to increase it at a steady pace and end up with 2000 somehow mapped on our graph. So what we can do, since we're jumping by 300 for 5 times, is we might actually be able to just put all of our numbers right here and still fit them. So let's see. Do 500 here, 800 here, 1100 here, 1400. Now we're going to be off by, wait, no, we'll be fine. 1700 and 2000. Perfect. So now our Y inputs are exactly lining up with our X input. Well, not exactly, but we have all of our Y inputs already mapped on tick marks and all of our X inputs mapped on our tick marks. So we can easily go in and line them up. So 0 matches with 2000. That's here. 1 matches with 1700. Right here. And so on. So I'm just going to fill these in. And once I fill all of these in, we can talk about what this means. So here we have a graph of points that, as our inputs are increasing, the Y outputs are decreasing. And when we have something that's lined up perfectly like this, we call this a perfect negative correlation. And in this circumstance, R is equal to -1. So you can go ahead and graph this chart right here to try to see if you can find what this value will look like. And then, yeah, so go ahead, pause the video, try to do that, and I'll talk about that after. Filling out this chart, by plugging in all of our x values, you should get the outputs of this, or what I have in the y column. Sorry, what I have in the y row. I didn't put any tick marks on this graph because I already know that this is going to decrease by 1800 every year. So as the years increase, the value is going to decrease. So we again are going to see a perfect negative correlation. And that is the end of chapter 3, section 1. So this should be the last video I do for a while. I hope this helped you out. Let me know if you have any questions.